please write down in a comment box whether I am audible or not. Hello, EM, then Suraj, then Shaq. Good evening to all of you. Good evening, everyone. Okay, please share it. Start now. This is my small introduction. You can join me there in my Telegram channel also. Like, can you solve this problem? Can you solve this problem? The present load produces 4 mm deflection at Z to produce deflection of 6 mm and 4 mm at X and Y respectively. Load required at Z would be. Those who have attended the morning 11 a.m. session on app, they will be understanding it. Here you can simply apply your Betti's law. Can you just apply and tell me what answer you will be getting it here? Can you apply your Betti's law to get the answer here? Simply you apply here your Betti's law and just tell me what will be the answer. As you have heard, you have learned in morning session that virtual work done by P system of forces. One system of forces, suppose P system of forces, whatever the virtual work done by them will be equal to the virtual work done by another system of forces. That is your Betti's law. Now here, one system of force which is including 20 and 30 kilonewton, that is producing a deflection of 4 mm at the center. Now, what will be the answer for this one? Can you just tell me? I'm counting on you. Okay, so here you apply. So deflection produced by this system of force, that is 4 mm multiplied by, suppose I am going to keep a W at this location. So W into 4 mm produced by another system of force, that is virtual work done, must be equal to, when you are keeping the load W at the center, the deflection produces are 6 mm and 4 mm at these two places at X and Y. So I can write down the virtual work done by the another system of force, that is 20 kilonewton here, multiply by 6 mm you are producing just beneath the X and 4 mm you are producing beneath the Y. So that is 30 into 4. How much you are getting W? So 120, 240, 4, 60 kilonewton. That's all. Simply by applying your Betti's law. Simply applying your Betti's law, you can get this type of problem very easily. Now can you solve this one? All the three rods of same length and symmetrical loaded at O, all are inclined at theta with the vertical deflection at O. Once again here you can apply your Castigliano. Can you do that? You can simply apply your Castigliano for this type of problem. If it is, first of all, see, one thing you have to keep in your mind, if it is a type of the frame which is having hinge at every location, this is nothing but your type of truss only, space truss, right? All the member will be having only axial force. Now if everyone will be having axial force, what is the force which is going to get generated inside the member? That I don't know. So consider maybe F is going to get generated here. F is the member force which is going to get generated here, because he is asking the deflection at O. So to get the deflection at O, as per the Castigliano, what we can do? We can calculate the strain energy. We can calculate the total strain energy of the system. Then just you partially differentiate with respect to the load which is applied at O, and you will get the vertical deflection at O. That's all. To get that, first of all, we need to calculate the strain energy, isn't it? Now to get the strain energy also, if only for the truss or axial members, what is the total strain energy? Summation of P square L by 2A, isn't it? Now that P force which is going to come over each and every member, that actually we don't know. How you will calculate that? So let us consider some F force are there. So I can always write it down. See, if they are equally spaced and everything is symmetrical, one can say that if theta they are constructing with the vertical one, yes, then the vertical one will be, if this is theta for all of them, then f of cos theta you'll get for each and every member. Now f of cos theta, 3 members are there, so I can write down summation of fy equal to 0. By using the equilibrium condition, I can write down 3 times of f of cos theta is equals to total p. That f will become simply nothing but p by 3 cos theta, isn't it? P by 3 cos theta. Now you got the member forces. You apply now. So total strain energy, if you want to calculate summation of all the strain energy, how much you will get? Summation of, see, you have a 3 member, everyone has this much force, so just multiply with 3, and PL is P square L by 2AE, isn't it? P square L by 2AE. So now P square L by 2AE, if you do here, okay, so P square divided by P square, that is P by 3 cos theta, P square L. What is the length of the member? Maybe it is L only. L, length and symmetrical. So all of them suppose has a length L. P square L by 2AE. Summation of that 3 I have already multiplied, 2AE. Right? Then this is your total strain energy. It will become 3 square. So 10 will get cancelled. So you will get P square L by 6. No, 3 will get cancelled. 6 AE cos square theta. Now you differentiate partially with respect to p. How much you'll get? 2p and 2 will 2 3 just 6. So a partial differentiation if you'll do, that is del u by del p. How much you'll get here? P L by 3 a cos square theta. That's all. PL by 3a cos square theta. Right. That is all about force method. Whether you are using Castigliano or you are using your unit load method, or you can use your consistent deformation method. Now can you solve this one? This is also similar to the previous one. The two identical wires of the same length and cross-sectional area inclined at 45 degree to the horizontal. A load P is acting downward, vertical deflection at O. Now if you want to calculate it simply, you will get the two component from here. If it is 45, although it is not important, because both sides will get 45 only. Suppose the member force has F, so I can write down that twice of the F sin theta, or cos theta, whatever you want to write it down, must be equals to P, the load P which is acting here. And similarly you will get the F force here, that is nothing but P by 2 sin 45, 1 by root 2, root 2 will go up, and simply you will get what? P by root 2, isn't it? P by root 2. That is the member force you have. Now what is the strain energy you have? Total strain energy will be summation of P square L by 2AE, or if you do that summation of P square L by 2AE, I can say that we have two members, so directly multiply by 2, and the force here you have P by root 2, that is P square L by 2AE, Now how much you will get here? That is P square L divided by 2 will get cancelled, this 2 will come like this, and then you just partially differentiate with respect to P. Partial differentiation with respect to P, and you will get simply PL by AE, isn't it? Simply you will get PL by AE. Now find the horizontal displacement at the roller support. For this arch, for this semicircular arch, what will be the horizontal displacement at the roller support? Once again, if you are applying the force P here, you will get the reaction P at this location. Now what will be the horizontal displacement? You can apply once again your Castigliano to get the horizontal displacement. Calculate first of all the strain energy, right? What will be your strain energy here? See, strain energy is nothing due to the bending will be summation of m square dx by 2EI. Now problem is that here you don't have that linear one, you have a curved one. So you can write down that is nothing but m square ds by 2EI. If you see the bending moment at in one side, suppose if you are standing here, if you are taking this section, the load is at this place. So what is the perpendicular distance from your considered point? That is P into, if this is R, this is theta, this is perpendicular, and this is hypotenuse. So it is R sin theta, and simply the bending moment here you will get P into R sin theta. At some theta angle you have taken the section, right? So PR sin theta is the bending moment. You write it down, integrate it from 0 to 0 to pi by 2. Why? Because you cannot see, if you will integrate from 0 to pi, you'll get 0, right? So integrate from 0 to pi by 2 and just multiply by 2, you'll get the total strain energy. So total strain energy will become 0, twice of that 0 to pi by 2, and m square is nothing but p square and then r square sine theta, sine square theta. Simply instead of m you have written pr sine theta, and ds I can write it down r d theta divided by 2ei, how much you will get it here? So p square, 2 will get cancelled and you will get p square r cube divided by p square r cube divided by ei. 2 will get cancelled now. P square r cube by ei, then integration of 0 to pi by 2 sine square theta d theta, which if you integrate you will get pi by 4. So just keep it pi by 4 here, pi square r cube by 4 ei, and this is your strain energy. Partially if you will differentiate with respect to p, that is your total strain energy. Partially you differentiate with respect to p, del u by del p. If you will do, how much you will get? 2p, so 2 will get cancelled. I will get pi p r cube divided by 2ei. That's all. If you have any doubt, please let me know. Then you can calculate for semicircular 2-hinge arch. Okay, there is a 2-hinge arch here, 2-hinge arch of a semicircular. It is an indeterminate structure, yes. A moment of 20 Newton. Okay, I will take a moment of, suppose this is A. A moment of 20 Newton meter is applied at B. This is B, and suppose there is a point here at C. 20 Newton meter moment is applied at B. 20 Newton meter, suppose this is applied 20 Newton meter. If you are applying 20 Newton meter moment here, which produces a displacement of 0.5 centimeter in vertical direction of C. So suppose a vertical deflection produced by this one is in this direction, right? This is the vertical deflection produced at the section C, that is nothing but 0.5 centimeter, 0.5 centimeter. If a concentrated load of 20 Newton is applied at A in the vertical direction, it's not at A, at C. If 20 Newton is applied at C in the vertical direction, then rotation at B. Now, if I'll apply the load, which will be more visible, the black one. If you will apply the load in the vertical direction, that is nothing but 20 Newton, then rotation at theta. What will be the rotation at theta? This theta he's asking. Can you do this one? This vertical deflection has given us 0.5. Can you do this one? How to get the rotation at theta? So once again you can apply your Betti's law, isn't it? So virtual work done by, see, 20 Newton if you are applying, it is producing a moment here, sorry, a rotation theta here by 20 Newton, and the moment if you are applying, it is producing a vertical deflection. Now that vertical deflection, simply I can write down 20 Newton into 0.5 multiply by 10 minus 2, make it meter. This is the virtual work done. This is 0.5 centimeter has not been produced by vertical load which you have provided there. And one more thing you can see here, the load and the deflection direction is also opposite. You can take minus sign. Then the theta when it is produced by 20 Newton, multiplied with the another system of load, that is 20 Newton meter. Here also you are applying the moment, and due to the application of the 20 Newton, the orientation will be opposite. The theta angle will be opposite to that. Once again you apply a minus sign at this place. So you'll get minus of theta into 20. This is just your virtual work done. This is also your virtual work done. From here, just you calculate the theta. 20 will get cancelled. Minus minus also will get cancelled, and you'll get 0.005. That's all. 0.005 radian. 0.005 radian. Now this problem is also good one, but actually it will take some time to calculate. A frame EFG is shown in the figure. All the members are prismatic. The member FG carries a uniformly distributed load W per unit. Axial deformation of the member is neglected. Consider the joint F being rigid. The support reaction at G. Support reaction at G. You can easily identify. The thing is that this is your indeterminate one. Now what will be the support reaction at Z? How will do this one? Once again, what we'll do? It is the indeterminate one. We'll consider this reaction as a redundant one, right? This reaction we can consider as a redundant one. See, in fact, you can say that method of least work or Castigliano's second theorem both are same only. You can apply this one, right? So total strain energy. So redundant force must generate in such a way that total strain energy of the system will become minimum, isn't it? Or instead, you can say that the total strain energy you calculate and just partially differentiate with respect to R. It will produce the deflection displacement at your joint G in the vertical direction. That G already we know that in the vertical direction is no more, so it is a 0. So you just equate del U by del R equals to 0. That's all. But to do that, first of all, you need to calculate the strain energy, isn't it? First of all, you need to calculate the total strain energy. Just calculate the total strain energy here. Calculate the total strain energy here. Calculate one by one. Just consider one section at, see, strain energy will be calculated for these two. See, this type of question also used to come in your gate examination, which you have to solve it. So strain energy for the complete system you need to calculate. So always you have to take, at x distance you calculate the strain energy for the member FG. Then once again you take the section for FE and calculate the strain energy, and then sum it up. So let us calculate the total strain energy. In fact, I can take the another slide also for this one. It will be better. So take the section here at some distance x, right? Suppose at xx I am saying that. What is your bending moment? Let me write down. Sorry, what is your strain energy? First of all, strain energy is, I am going to write down strain energy for FG and strain energy for EF. Strain energy for FG and strain energy for EF. Right. Now let us write down one by one. For FG, what will be the strain energy for FG? Suppose if I am considering a section at x distance, so the bending moment will be, this reaction already have considered as R. Reaction if I have already considered as R. So 0 to L for strain energy for FG system, right? 0 to L and m square dx by 2ei. So bending moment will be simply, see, R into x will produce sagging, minus the UDL W into x square by 2 will produce hogging. So W into x square by 2, right? This is your bending moment, isn't it? Dx by m square dx by 2ei. Did you get that? Then what? Add 0 to L. Consider another section, maybe here at some distance, maybe x, right? What will be the bending moment at that location? So bending moment at that location will be nothing but, see, R into L is the fixed one. R into L constantly it will be there. Then RL minus same WL square by 2. W into L. L is the length, so WL square by 2. WL square by 2. This is your bending moment. That is m square dx by 2ei. That is the total strain energy. That is the total strain energy in EF and FG. EF and FG. Did you get that? Now, you calculate the strain energy, and then what is your purpose? You are going to partially differentiate with respect to R. You do it now only. It will be slightly it will become easier for us to do the calculation, isn't it? Now if you partially differentiate, what exactly you will get 0 to L, and twice of this Rx minus Wx square by 2, which will be multiplied by del u by del r. You are doing del u by del r, so you will get only x here, right, into dx by 2ei, then plus 0 to L. Here also if you partially differentiate, you will get twice of RL minus WL square by 2, and then you will get L, correct, dx by 2a, right. Then you equate it to 0. Partially differentiating, either you say it is a method of least work, or you can say it is a method of Castigliano, doesn't matter, right? So total, strain energy will be minimum. Our redundant force will generate in such a way that total strain energy in the system will become minimum. Now partially differentiate, how much you will get here. Is it visible to you after that? I think it is visible. Okay, then just continue. So after partially differentiating, how much you will get here? 2 will get cancelled. Ei I can take common. Ei I will common, and the Ei I will send it towards that side, so it will become 0. And then Rx if you integrate, it will become Rx square, isn't it? Then x square, if you integrate, it will become x cube by 3. So I can write down 0 to L. No, I will directly write down RL cube by 3. What do you say? RL cube by 3. Then see, already these two will get cancelled. This 2 get cancelled. Ei I have taken common, I send it to that side, it is already gone. Then Rx into x will become Rx square, Rx cube by 3. So 0 to L, it is become RL cube by 3. Then minus Wx cube by 3, so it will become Wx4 by 8, and I can write down WL4 by 8. That's all. Then what? From this side RL square, so RL square into x, it will get RL cube, right, RL cube. Then correct one, no? Then minus RL x, then RL, okay, WL square by 2, WL cube by 2, and hence it will become WL cube by 2. So then L, so WL4 by 2, WL4 by 2. Is it correct? Must be equal to 0. Now if you calculate R, you will get from here 0.48 WL. Right. See, this type of problems also used to come sometimes. Actually, it will take a time a little bit. This type of problem. Did you get that? So answer is 0.482L. Then you can solve. See, this is also, once again, you can apply Castigliano. He's asking about the truss. What is the horizontal displacement at joint A? This is your joint A. So horizontal displacement, if it is asked, either you can apply the unit load method, or you can apply your Castigliano. Suppose now I'm going to apply maybe Castigliano. You can apply, see, any of the method can be applied. Either you apply the unit load or you apply the Castigliano. Both are okay. Only. Right. Now apply that, maybe, or apply unit load. Already we have applied so many Castigliano. No? You apply the unit load. So to apply the unit load, what you have to do? Due to the external, see, first of all, you identify zero member forces. Maybe those who have attended the classes, maybe when I will conduct the for Truss, then I'll tell you how to calculate the zero member force. For just now, you understand that 3 member forces are there. This will become 0. And here also 3 are meeting 2 are in a one line, so this will be 0. 3 are meeting, 2 are in a one line, this will be 0, 3 are meeting, this will be 0, 3 are meeting, and this will become 0. Actually you have only the member A, B and C. You have only the member A, B and C. So for the member A, B, C, okay, quite visible. For the member A, B, C. Now if you are applying your unit load method, what you will do here? What you will do here? As I told you, summation of PKL by AE. That's all. If you remember, in the morning only I told you PKL by AE. Then just horizontal displacement at A is asked. Horizontal displacement at joint A is asked. How you will calculate? First of all, due to the external loading, calculate what are the member forces you are going to get. P of AB, P of AC and P of BC. So for that, actually you have to apply the joint method analysis. You have to do that, right? Joint method analysis. Now consider any of the one joint. First of all, maybe I'll consider B. Maybe I'll consider B joint. If you consider the B or C, whatever you can consider. This is your roller, no? Roller. Acha, due to the 2 kilonewton, what is the reaction? First of all, I can say that reaction will be, it is rotating anti-clockwise, 2 into 4. 2 into 4. So you will get the reaction which will rotate clockwise, and the reaction will be 4 to the 8, 8 divided by 3. Reaction will be 8 divided by 3 both sides. 8 divided by 3 here and 8 divided by 3. Consider the joint C. If you consider the joint C here, for the joint C, you have a member force F of AC, then you have a member force F of BC, and you have a reaction which is 8 by 3. You have a reaction which is 8 by 3. Oh, sorry, reaction is opposite to that. 8 by 3 reaction. Right? What is your theta here? Theta, if you'll see, this is 4, this is 3, so it will be 5. So sine theta and cos theta is quite easy to write down from here. Sine theta will become perpendicular by hypotenuse, that is 4 by 5, and cos theta will become 3 by 5. Right? Now component, you take that component of FAC, component of F of AC, you take it. This is theta. This will become F of AC sine theta, F of AC sine theta, F of AC sine theta, and this is F of AC cos theta. Then you apply summation of Fx equal to 0 and summation of Fy equal to 0. So summation of Fy equal to 0, if you will apply, what you will get? Summation of Fy, F of AC sine theta equals to 8 by 3, and F of AC I can write down. Sine theta is how much? 4 by 5. 4 by 5, so I'll get 10 by 3. 10 by 3. 4 by 5, it will become 5 by 4. 4 to the 8, 5 to the 10 by 3. Once you'll get the F of AC, you just simply write down the summation of horizontal forces equals to 0. Summation of horizontal forces means F of BC then plus F of AC cos theta equals to 0, which is F of BC equals to minus of F of AC already 10 by 3, and cos theta you have 3 by 5, isn't it? So 3 by 5, which will give minus of 2. Correct? Correct or not? Minus of 2. And here you already know that this is your hinge support, no 2 kilonewton, so you will get the 2 kilonewton in opposite direction. No need to think about it. This is very sure 2 kilonewton in opposite direction. Consider the joint B. This was joint C. Consider the joint B here, and from the joint B you can simply say that this is 8 by 3, and you got the value BC which was minus 2. Actually it was supposed to come. What will be the value of F of AB? So F of AB is quite simple. I can directly write it down. F of AB from joint B, if you see, F of AB will become minus of 8 by 3. Simply F of AB will become minus of 8 by 3. These are the member forces, I got it. Then according to the same one, you see, actually I am asking you the deflection, horizontal displacement at A, which is where already you are applying your 2 kilonewton. Now 1 kilonewton, just if you apply accordingly, you will get the K system of forces. Now the K system of forces, if you want to calculate, how it will be? f of AC. F of AC just you divide by 2, then f of AC will be how much? F of AC will become 5 by 3. Then f of BC will become minus of 1, isn't it? And f of, sorry, instead of that you write down K so that you can discriminate between these two member forces due to the external loading and due to the unit kilonewton load. K of BC. So remove that external loading, apply the unit load. What exactly I'm doing it here? I'm removing the external loading and applying the unit kilonewton load in the direction where I need the deflection. So 1 unit kilonewton load I'm applying here because horizontal displacement at A is my requirement, right? So once I'm applying 1 kilonewton, just I'm from as per ratio I'm just providing the values because this is the same location. If you are providing instead of 2, if you are providing 1, what will be your member forces? So K of BC have written here, then what else? 1, 2 and K of AB. Okay, K of AB will become divided by 2, that will become minus of 4 by 3. These are the member forces. You got it. Just what you have to do, if you want to get displacement in a horizontal direction at A, that is nothing but summation of PKL by AE. Just do that. So 1 by A you keep at side. Write down PKL for all the three members. So P for member AB, what is your P value? For member AB, I think we'll not be able to write it down here. So displacement at A will be PKL by AE. If you do that, PKL by AE, 1 by AE I'm just keeping aside, and PKL you do it for all the member. Like for AB, first of all, AB, what is the length of AB? Length of AB is 4. P, what is the P for AB? P for AB is minus 8 by 3. So minus 8 by 3 into K is how much? K for AB is minus of 4 by 3 multiplied by 4 is the length, then plus PKL for the member AC, that is 10 by 3, and for K of AC is how much? 5 by 3 into 5 by 3 multiplied by the length of the member AC is 5, then plus for BC, what is the member force BC? That is F of BC is minus 2, so minus of 2 multiplied by minus of 1 multiplied by what is the length of BC? That is nothing but 3. Just calculate all of them. Is it correct now? So 832, if you calculate, you'll get around 48 by A. So that is how you can apply. Instead, if you want to apply Castigliano here, what you have to do? If you want to apply the Castigliano, what you'll do here? If you want to apply instead of unit load method, assume that 2 kilonewton as P. Due to the P, you calculate the member forces, and with the help of the member forces, you calculate the strain energy, right? Then after calculating the strain energy, partially differentiate with respect to P, and you will get the horizontal displacement at joint A. Right? So these are actually force method generally which you are implementing. So gate examination force method slightly calculative side, more or less it is more calculation side. Tomorrow do not miss the session for slope deflection at 11 AM. So slope deflection in BYJU'S Prep app, Please join me on app for slope deflection. Then we'll continue with the slope deflection and moment distribution. We'll see the shear analysis, then how to do the problems from slope deflection, then sway analysis. All these things we'll see there. So from that's all. Generally from the force method, they will be asking either reaction, the redundant force reaction, or they will be asking some deflection, deformation. That's all. Joint deformation or redundant forces member. That's all from the force method they generally used to ask. That's all from my side. Thank you everyone. Good night.